Hello everyone and welcome to this video on Autodesk Fusion 360. In this video we're going to take a very brief look at the difference between bodies, components and assemblies and how Fusion 360 deals with these. Okay, so I'm in my normal design environment within Fusion 360 and the first thing that I'm going to do is I'm going to create a block of material using an extrude feature. So inside my design I can go to create a sketch, I can sketch on the XY plane, I can sketch a rectangle on the XY plane, and then I can use the extrude tool to extrude that rectangle to a given height. Now as soon as I do that, I've created an amount of material within my existing design, and I can see this bit of material if I go to the browser on the left hand corner and I go to the body section. I can see I have a body called body 1. Now we can think of bodies as bits or lumps of material within our existing component design, and it's possible to have as many bodies as you wish within a single component. The primary reason that we have bodies, or we're able to model bodies within components, is so that we can later use Boolean operations in order to create component forms. Now what do I mean by this? Let's imagine that I create another extrude feature. So if I sketch on the top of this face, again I create a sketch, again I create a rectangle. I'm just leaving all of this unconstrained for now, and again I create an extrude feature. Now as soon as I go to create this second extrude feature, I have a choice in the operation section of the extrude dialog box, and by default this will normally be set to join. If I leave this as join and press OK, I will see that I still have one body of material in the browser on the left hand side. If however I go back into that extrude feature and I edit that feature, and instead of joining I select new body and press OK, I'll now see that I have two bodies within the bodies folder in the browser, body 1 and body 2. And then separately in another operation I could choose to join these together. So I can go to the modify section and I can go to combine, and this will allow me to select both of these bodies, join them together and press OK, and again that would result in me having one body of material. Now at the minute it might seem like quite a useless approach doing something like this, but we can actually use much more complicated combined commands. So let's imagine that I do a third extrude feature, but this time instead of extruding on the top face of this component, I'm going to create a plane at an angle. So I'm going to go to plane at an angle, I'm going to select this corner here, I'm going to make this something like 45 degrees, and then I'm going to sketch on this particular plane. And I'm going to create something which is reasonably complicated. So let me use my spline tool. I'm just going to create a spline shape there and finish the sketch. I'm then going to extrude that shape, and I'm going to extrude it symmetrically, something like this. Now by default Fusion will assume that I'm using a cut operation here. But I don't want to do that. I want to make a new body, and I'm going to press OK. And what that means is I've now got my that body I've just created for this this new extrude, and I've got the existing body that I created by combining the two initial bodies. So now I can go to modify and combine, and I can pick these two bodies, but instead of just joining them together, I can use I can select some different options. So if I go to cut, it will use one body to cut away another body. If I use intersect, it will preserve only the material in the volume which is occupied by both of those bodies. So this is what I mean by Boolean operations. So if we've got a particularly complicated or complex form, what we can do a lot of the time is we can build up individual bits of that form using different bodies, and then use a Boolean command at the end to either do a cut operation or an intersect operation, and this is just one good way of creating complex forms, and that's primarily why we have the bodies functionality within Fusion 360. So if I just leave that as intersect and pressed OK, I can now see that I've only got one body of material, and that's body 1. Now, whenever we finish modeling a component, we can use all of these different bodies and these Boolean commands and everything as much as we want throughout the component, but it's generally good practice that when we are finished and our component is complete, that we only have one body of material within our component. Okay, so hopefully that properly explains the difference between bodies and components. So next, let's think about assemblies. So Fusion 360 deals with assemblies quite differently to a lot of different CAD packages, and the reason for this is because it offers quite a lot of flexibility. So there are two primary approaches for assemblies. We can either do what's called assembly modeling, and we can create all components for a particular assembly within a single design, or we can use what I call a drag and drop approach, where you model each component individually and then you drag it into the assembly. So I'm just going to start a new design to illustrate this. So let's have a look at the first approach, assembly modeling. So what I'm going to do here is I'm just going to try and create an assembly for a bolt within a block. We'll keep it nice and simple, just two components. So the first thing that I want to do is I want to create a bit of material for my block. I want to create a component for my block. So I do this in the normal way. I go to create a sketch. I'm going to sketch on the XY plane. I'm going to create sketch a rectangle, and then I'm going to sketch also a circle in that, which is where my bolt is going to go through. I'll make this 6.5 as though we're doing an M6 bolt, and I'm going to finish that sketch. I then go to my extrude command, and I can extrude that shape as tall as I want, and then press OK. So at the minute I have a single body of material within a single component. So best practice for assembly modeling in this way is to create, if you're making multiple components within a single design, is to create those components as soon as possible. So if we go back to our extrude dialog box, if I edit this feature, rather than creating a new body, I sometimes will have the option to create a new component here as well. Now it's not giving me that particular option right now because this is the very first operation within this particular design. So we're going to take a different approach for now. So if I press OK here, and within the bodies in the browser, I can right click on that body and I can select create components from bodies, which is just here. Now as soon as I do that, I see that my design has no longer got a bodies folder, so it's got no bodies in it, and I've got this component here, component 1. And this component will be my block. So if I want to give it a name, I can right click it and I can rename this, and I can call it whatever I want within the browser window. So we'll call this block. Okay. When we have multiple components within an assembly, and we can tell that this is an assembly now because the icon next to the assembly name has changed. It's no longer just a cube like this, it's a collection of cubes, which indicates we are working in an assembly. Whenever we're working in an assembly like this, we can activate different parts of that assembly. So at the minute I have the top level assembly activated. If I wish to activate this block and change details about this block, I can press the little radio button next to it and I can activate that component. To better illustrate this, I'm going to create the bolt component first. So I'm going to activate the top level assembly, create the bolt, and then I'll show you exactly what happens when you activate different components within an assembly. So this time I'm going to create a sketch. I'm going to sketch on this top face, and I'm just going to create two circles which will represent the shaft of my bolt and the head of my bolt. I'm not going to worry too much about the detail for now. Let's make this something like 10. Make this something like 6. Okay, so the first extrude operation I'm going to do is for the head of my bolt. So again, I go to extrude, and I'm going to pick all of these areas that I've just sketched, and that looks about right for the head of my bolt. And I can see this time within my extrude command I've got the option to create a new component. So I'm going to create a new component here because I want the bolt to be very different to the block. So I'm going to press OK. As soon as I do that, I can see that I've got component 2, and I've only got the head of the bolt in that particular component. So what I want to do now is I want to create another extrude. So if we go to extrude, and then I'm just going to extrude the shaft of the bolt here, and I'll leave that as join because I want to join it to that existing component, and press OK. So we can see what I have now is I have block and I have component 2, and again I can double click on this and rename this to bolt. So I now have an assembly, or a top level assembly, with 2 components in it, block and bolt. Now, one very important thing to point out here is where sketches are stored when we create components in this manner. So for this initial block that I've created here, we'll see that if I look at my block component, I only have a body. And if I activate that component, in fact, I'll see that I've got no design history at all, other than the creation of the component from bodies feature here. So where is that sketch that I originally created? Well, the sketch is actually, if we turn it on, in the top level assembly. And the same goes for the bolt component as well. We can see that sketch in the top level assembly. So we need to be aware of this when we're making assemblies in this way. At present, there is no way to make sure that these sketches are actually within the feature tree for that particular component. So we need to create that sketch, and then the very first opportunity we get, we need to create our new components. Otherwise, we end up dividing features between the top level assembly and their respective components. Okay, so just one final thought on this is the how we activate individual components. So for example, if I decided that I wanted to add some fillet features to this block, at the minute I've got the top level assembly activated, so let's activate the block by clicking that radio button, and we'll see that everything else in that assembly goes transparent, and that indicates that I'm working on this block. If I go to fillet, I'm just going to pick a couple of edges on here and put 5mm fillet on, maybe a bit too much. Let's try 2mm fillet. And what we'll see is by activating that component and then making that change, that fillet feature is inside of the block component. So if you ever need to change this, we know exactly where to find that feature in the timeline. Had we left the top level assembly activated when we made that feature, we would find that fillet feature in the top level assembly. This is probably the most important part of assembly modeling in this way. We really need to make sure that we create the component as soon as possible, and that we have the right component activated when we need to make changes to that particular component. And this keeps our feature history, our feature timeline nice and clear, and it makes it easier to edit the component in the future. Okay, the other approach that we have for assembly modeling is what I call the drag and drop approach. So in this particular approach, we create 2 individual components and then we drag them from our data panel into our new design. So in order to do this, I'm just going to quickly create a design for a block. And I'm going to quickly create a design for a bolt. fix that extrude feature. There we go. Okay, and now I'm going to create a separate design for my assembly. So if I first of all save this, because you won't be able to drag and drop until you've saved it. So I've now got a saved block component, and we can see this is a component because we've got this single cube icon next to it. I can see I've got a single bolt component, and at the minute I've just got a blank design named block bolt assembly. So if I open up my data panel, I can see these two components that I've just saved. So I can drag in the block, and it will just drop that into my design for me, and it will give me by default the move copy dialog box as soon as I drop that in. So it's asking me where do I want to place that. I don't want to move that just yet, so I'm going to press OK, and I'm going to drag the bolt in also. And you can see it sort of put that halfway inside the block, so I'm just going to move that slightly outside and press OK as well. So now I can see that my icon has changed. I've got the collection of cubes, meaning that this block bolt assembly is now an assembly. Again, I can see two components here, but instead of, or in addition to the component names, I have this other icon which looks like a couple of links in a chain. And what this is basically saying is that these two components are linked to external geometry or external components. So if I want to make changes to either of these components, I need to separately open up either the block component or the bolt component and make changes, and they will be reflected in the assembly. So I'll show you what I mean by that now. If I go to my inspect tool and I inspect the diameter on this hole, I can see that this is a bit big. This is just over 9mm, and actually I want it to be 6.5mm to match the bolt that I've created. So to make a change to this particular component, I need to go back to the block component here. I need to edit my sketch and put the appropriate diameter on the circle that I've created. So I'll make this 6.5, so that will make that hole smaller. I'm happy with that, so I can press finish and I can save that as well. Now if I go back to the block bolt assembly, I will see this icon, this warning triangle at the top of my window. This is telling me that a particular component is out of date, and I need to update my my view in order to show the latest component geometry. So if I just click that icon, it will get all of the latest components. We can see that it's reduced the size of this hole to match the latest block design. So if I want to make changes to either component, that's what I need to do. I need to go back into the component, make the changes, and then update them within the assembly. If we make components in this way, we also find that they're completely free to move around in space. So when we're creating an assembly, there is often a need to constrain the position of components relative to one another. So we do this within Fusion 360 using joints. And I'm going to quickly do one of these joints now. The subject of joints will be the topic of its own separate video. So the way in which or the general approach for creating joints within an assembly is to first pick a major or an important component, and we ground that component. So in this particular design, that will be the block component. So we can right click on the block and we can hit ground. When working with assemblies, you will get this dialog box quite often. What this is asking is, or what this is telling you, is that you've moved the position of these components since you brought them into the assembly. Do you want them to retain their existing position, or do you want them to snap back to their original position? At the minute, I don't want to capture position. I want it to go back to where I want the block to go back to where it was when I brought it into the assembly. So I'm going to press continue. We'll see the block move there, and we'll now see that there's a little drawing pin icon next to the block component name, meaning that I can't click on this and drag it anymore. I can still move the bolt, but I can't move the block. Once we've grounded a component, we can then start applying joints between any other component and that particular component. So if I go to Assemble and I go to Joint, again, it's going to ask me if I want to revert the position of that bolt, so I've just moved it. This time I'm going to press Capture Position and it's going to stay where it is. So inside the Joint dialog box, we're basically being asked for 2 references on 2 different components. Now the best way to think about joints within Fusion 360 is you are creating a single joint between 2 components, and we are bringing together 2 points in space and fixing them together, and then we are potentially allowing additional degrees of freedom if we choose so. So for example, for this bolt, I would like to snap this center of this face to the center of this hole. So the way in which I do that is I hover over the edge, not the point itself, I hover over the edge, and I can see that I get an icon in the middle of that circle. So I can see that I've selected this point here, and I can do the same on the bolt, and we'll see how it's brought those 2 points together in space, and it's rigidly fixed them together. So if we go into the Motion tab of the Joint dialog box and press play or animate, it will show you what what relative movement is allowed, and at the minute these components can't move relative to one another because I'm using a rigid type joint. If I go back to position, we can obviously see this bolt is not in the correct place. This will happen quite a lot. All we need to do is use the flip icon to flip that round into the right place, and hopefully we can see now that bolt is properly positioned within that hole. If we go back to motion, we have some options here. So by default, you'll be applying rigid joints. This means that one component is fixed rigidly to another, but we can enable additional degrees of freedom if we want. So for example, if we go for a revolute joint, we'll see how this bolt is now allowed to spin within the hole, and indeed we can pick any axis to allow that component to spin about. Slider will allow it to slide up and down within the hole, and then we have additional joint types: cylindrical, pin slot, planar, and ball. I'm going to leave this as rigid for now. As I mentioned, there will be a separate video on different joint types and how to apply them. So hopefully that is a brief overview of the difference between bodies, components, and assemblies within Fusion 360, and how you should be treating those when creating your own designs. Thank you very much for your time, and I will see you in the next video.